Hello, everybody. Yeah, I was able to sit into a little bit of the keynote, and that was some really good thoughts there, especially how our brain is changing in the way we digest information, and you know, some of the things that we've set up in the past, the way we do business, might not apply anymore. And it's exciting to see new techniques and new ways of doing things. And one of the things that I'd like to get out of this experience is hearing from you what ideas you have. So feel free to jump in, ask questions. At the end, there's a kind of brainstorming slide if we have enough time. So, but I really see that as a value of having everyone here together today. So, you know, it is 2017, and we are without a spacesuit display. In every movie that has a spacesuit, you see all the fun information in front of Tony Stark's face, and it's guided there. It knows where his eye is. It knows what he wants to see. He doesn't have to pull up menus or click anything. And this is what everybody thinks NASA is doing right now. And I'm here to unfortunately tell you that we are not. But there are people who are pushing the limits on their own even. There are, I may be out of range of this thing. There we go. So this is Richard Browning, the good fortune of hanging out with him on one of his speaking panels at Comic-Con, and he built his own jetpack, and he needs a lot of information about how his engines are operating, or you know, if anything malfunctions and he's 30 feet up in the air, it's not a good day. So he has that information fed to him through a helmet that's off the shelf. It's used in chemical plants. It's the daiquiri, I think, and that's just the way he's solved those problems. He's able to get stuff off the shelf. Most of what he has strapped to him is off the shelf, and that's the type of the type of philosophy that we're starting to take at NASA as well. So I'm here to also explain a little bit about what our spacesuits are really like. So if you can follow me here, there's a camera in front of this as a reflection off the helmet bubble, so it's not exactly the view of the crew member. But you get to see what he sees, what he or she is looking at during the whole EVA. And you see that small display in the bottom, that's a 2-line LCD dot matrix message display. And that's the extent of our informatics right now. They suit up and they have procedures that they go through and flip physical switches and look at physical gauges and then read the messages on that display. This is entirely clear, hopefully, not fogged up or water in it or anything. So this suit's been around since the 1980s, and we are excited to be working on the next generation suit. So our philosophy on how we develop our displays in general for space, we're seeing the trends of the world, and in so doing, we can fly up commercially off-the-shelf equipment, and this is Scott Kelly last year trying on the HoloLens, and he loved it. He wanted to see more applications in that environment. And so one of the, you know, not only can it be a means to get to where we're being, but we want it to be a goal to have immersive technologies be in the playing field when we have displays on orbit. And in particular, when you think about the spacesuit, we don't want the displays to be that much different than what they're used to seeing every day. So we want to maintain that continuity between when they're in the cabin and when they're in the suit. So just a little background. I was here last year and I gave a talk on a similar subject about how we can use immersive technologies for systems engineering in general. And I run a lab, the Human Integrated Vehicles and Environments Lab at NASA Johnson Space Center, and we do exactly that. We have immersive environments, cabins and mock-ups of Orion, and we also have integrated in the last 6 or 9 months the HTC Vive. And so in the very early days of testing, this is a screenshot from the video I took. I was just playing around with the model that we have of that building and a mock-up that we were looking at building. And we kind of developed a way to explain what the design was going to be about, put that in front of the engineers. The engineers could then visualize it even better and come up with ways to design it better, or they might highlight problems or areas to study a little bit more. And so that same philosophy is going into the spacesuit that we're going to build. So right after that talk, our group, the Avionics Systems Division, was asked to participate in the design of this suit. And this is a cartoon. So we have, soft goods that haven't been quite designed yet, and informatics that haven't been designed. But the main three parts of the suit are the life support system, the backpack, the soft goods, the pressure garment system, so everything that keeps the pressure inside, including the helmet bubble, and then the informatics. The informatics are the non-life critical avionics that help the crew member be more efficient and effective out there. So we've had some public conferences to show the world where we're at, where we need help, where we need to partner. This is where you can get some more information on those materials that we've put out in the world. So nasa.gov/suitup, and then you can go to the workshop that we just had, this technical workshop. But here you see one of the program managers explaining where we were at with this PLIS design. So we have prototypes, 2.0, 2.5, and it goes on. These packaging exercises have been going on for literally decades. We've been designing our new suit for a while now. There's good and bad with that. We're very confident in that design. We think that it will perform far better than the suit that we have now. But that's still technology and we can afford to make it a few years old. It's tried and true. We have a lot of data on it. Informatics is something different. Every year we see the technology just skyrocket. So we don't want to lock ourselves in on the informatics side. And that's the team that I'm leading at Johnson Space Center. And we call it XInfo, the XEMU is the next suit, but it's more than just displaying data, because you might think of just the display as being all that it is, but it's to make you more efficient. But there's a lot that's in the suit already that can make you more efficient, just in the form of lights and cameras and things that help not only the user in the suit, but the one on the ground. So our XInfo team, small team up there in yellow, all of them contributed to what you see here today. We're based out of Johnson Space Center. It's built on years of development in field analogs. At Glenn Research Center did a lot in the last 10 years. And it's relying more and more heavily on university partnerships and SBIRs and other contract mechanisms. We're trying to reach out there and keep the pulse of the technologies that are there, so we can not create our own path towards this solution. We want to be on the same path as the rest of the world. So, but our purpose is to make these EVAs more efficient and effective by reducing the workload on the end user. So that's different than keeping someone alive. And EVA is a spacewalk, extravehicular activity. So that purpose boils down to three aspects of a mission. We're looking at the data. We're collecting the right data and turning it into actionable information. And then we have to communicate this information to the end user. Now, the end user may not be the person in the suit, but they are part of the operations. So you look at those operations of actually performing the task. Anyone who has an active role in that is an end user. And if you think about it, this is a systems engineering problem, not just a HUD problem. But the most challenging part is the HUD. So just a little overview of the informatics that we have. So the same picture before, and you see all of the things that make the user, the end user, so not only the crew member, but this camera assists the ground in the situational awareness of what's going on with their task. The lights illuminate that task. The paper cuff checklist, just in case they lose communication, they have kind of a backup plan. It is paper. This DSLR, this is a Nikon camera just packed in protective material. That helps the engineers that are getting their stuff installed, making sure that it's installed right, so that if something goes wrong, they can trace it back. And then we have, again, the small LCD screen that displays the information. So what challenges we have in the future? We have a latency problem. So latency is where you have the delay between the light speed of the ground to your end EVA crew member. That's pretty well understood, and we see it every day when we see an interview on CNN, or when you're on a bad cell phone connection, it's routed through your home router and somebody's streaming a video. You have a few seconds of delay and it's kind of awkward to the other person, but we get over it. And that's the kind of delay we're looking at for the moon. But as you know, it makes you less efficient. And when you're dealing with so much information, it's really important to be as efficient as possible. Add to that every piece of information has to go over an audio link right now. That's our real problem. So the bandwidth of this data that goes over that audio loop, it's just, it's packed with it right now. And so what we're looking at doing is taking that and turning it into pictures worth 1,000 words, and we need to look at different ways to display it. So we've come up with plenty of ideas. This electronic cuff checklist has made it to the Martian. Matt Damon had it on his wrist, and all of these video pop-ups where you can talk to someone and have that contextual, facial expression we see in movies all the time, and we use it in our day-to-day lives. We have Skype meetings instead of just emailing each other back and forth. So we know that it makes us more efficient. So we have to figure out how to put it into a system, maintain the level of technology that everyone's used to, but also be aware of this criticality of, this latest technology might not be as reliable. So we need to separate, well, if we're going to Skype a command to save the crew member in an emergency, well, maybe we need to design a system that's 3 fault tolerant to make sure that happens, no kidding. So we're separating out those criticalities. The informatics is by nature what we call Crit 3. Crit 3 is non-life critical, but makes the spacewalk more efficient. There's Crit 1 items that are all throughout the backpack, and they keep the pressure in, and they make sure that the crew member stays safe. If you had one but not the other, things would be either boring or bad. So what are we doing in the Hive? So in the lab environment, we have the HTC Vive, and we're trying to take a 2-tiered approach. What is ideal to see, and what can we see today? So the ideal approach is wide open. Like, where are your displays? What do they look like? Do we model them after displays that are used to seeing in the cabin, or are those too complicated and we need to pare them down to something more simple? So we had a few Rockstar interns come in and some game developers, and they made an environment that you could take displays off of a virtual table and paste them to your helmet. Now, that may seem trivial at first, but when you think about the way the helmet in the suit is oriented, it's not fixed to your face like a VR helmet. It's floating when your face can move back and forth and around. That means your eyes are moving around. And to converge on an image, unless you have really good vision and can see something, read it right there, even if you do, and you've got a task in front of you, that's very straining. So we need to figure out a way to have images converge at the distance that's comfortable to the user, as well as having each eye see something different so it converges in 3D. So we're getting to that. We're looking at that, but at the same time, we also need to figure out, well, what's the ideal state? So when we hook this up, the ideal state for a head-mounted display that follows your head might be different than one that sticks with the helmet. So the way we simulate that is we actually took one of the HTC controllers and put it on a backpack. That's the suit. That tracks the suit. Now the helmet is floating inside, the HTC helmet is floating inside the spacesuit helmet virtually. And so we're able to move our head in a very limited fashion because we've got this backpack on. We're able to move our head around and look at that display from different angles, just as we would if the display were in the suit. So it was the bare minimum. It's not super high fidelity, but it gets us surprisingly close to feeling like we have a display stuck in our helmet. And then we can adjust the size, distance from the apparent distance from the crew member's eyes, and we're not sure what it is, HR, hybrid reality, or mixed reality, but it's kind of a mashup of them both. Another thing we've been doing is using this virtual environment that we developed for figuring out what our best displays were, for analyzing different engineering scenarios for the suit. So we have lights and a camera, and we're trying to figure out, well, what's the best camera? How can we get the best field of view? Is it blocked by the helmet in this new configuration? So we can very easily just slap a camera on in Unity and show that, even show a video clip of working at a work site, and give that to the engineers and say, no, that's not going to work, you need to extend it out or move it. And you have justification because there's 2 other subsystems that are very mature. They know exactly where they want to put everything. And when you say, I've got a camera to install here, they freak out. So, so that's, we're trying to figure out where the ideal state is, where the ideal display is. But what about the HUD, and what can we do? How possible is it? What about that resolution of your resolving that display in a comfortable manner? We're getting to the point where we want to understand that problem a lot more. And so one of our longer-term interns, Paramita Mitra, she developed, along with Physical Optics Systems, POC, Physical Optics Corporation, and through a NASA SBIR, developed a display that reflects down to the user through a little reflective see-through device there. It's bare minimum, but it's what we can do now, what we can do in the lab, and we can play around with that configuration and make it better and better over the years, working towards our end state. Another way that we do this is years ago. This is in preparation for a Desert Rats analog mission. If you're familiar with analog missions, we bring the best of what we've designed and bring it all together. It's a way to have an integrated solution in a representative environment. So in this case, it's out in the desert, walking around, interacting with some payloads, and trying out rovers in a mission scenario, in a little bit more of a serious environment than the lab is normally in. All right, so one thing I wanted to announce, this was just announced last week, is there's an opportunity to help. If you're a student, or if you're faculty and you want to bring a student team together, NASA Suits is the spacesuit user interface technologies for students. And what we're using is the Microsoft HoloLens to provide the environment for a heads-up display for a virtual crew member to run through a procedure that we've contrived for the exercise. What this will do is give us a chance to see a variety of ideas on how not only the display, but the interaction works. So when someone's out there doing a task, they might not want that procedure just overlaid on their task because they're trying to see the task. They may want a combination of some very low touch displays to the side, plus some audio keys and triggers. They may want to listen to the audio and find out where they are in the procedure just in the background, just automatically. If that comes out of this, that'd be great. So this is the first time through, and we're just using Microsoft HoloLens. Our vision is to have it extend into virtual reality next year. So hopefully things go well. We can have two tracks and have some of that more like whiz bang, maybe closer to Iron Man, but the Microsoft HoloLens is what we're constraining it to this year, just to get our feet off the ground, and we're really excited to kick it off. We had a couple of Q&A sessions online with some interested folks, and they were pretty fired up for it. So if you had any questions about that, there's an email there. You can send it anytime. I can try to answer them here if you'd like. But I would like to hear some thoughts, because last time I think there were a few pieces of feedback that I went and researched and really kind of shaped the work past that. So this is just a great environment to do that in.
If